We're about to dive into one of the most ambitious energy projects on the entire planet. India's quest to completely reshape its future. Now, this isn't just about switching away from fossil fuels. No, this is a massive, multi-generational bet on a single element that could, quite literally, power the nation for centuries. And really, it all starts with this one monumental question. How do you provide clean, sustainable energy for over 1 billion people? We're not just talking about keeping the lights on. We're talking about fueling the dreams and ambitions of the world's most populous nation, and doing it in a way that's secure and self-sufficient. This enormous challenge is exactly what pushed India to think way outside the box.
So here's how we're going to break it all down. First, we'll tackle the problem itself, India's energy dilemma. Then we get to the really fascinating part, the thorium bet. After that, we'll walk through the incredibly clever 3-stage master plan they've designed. Of course, we have to look at the high cost of innovation. And finally, we'll ask the big question. Are we looking at a new nuclear dawn?
All right, so first things first. To really get why India is going down this very specific, very complex path, you have to understand the sheer scale of the challenge they're facing.
You've got a booming economy, a population that's still growing, and all of that means their demand for electricity is just skyrocketing. Relying on imported coal and gas forever, that's just not a stable long-term plan. And while renewables are a huge and growing part of the picture, they can't carry the entire load 24/7. This reality has forced India's best and brightest to get creative, to pursue a path that feels almost like science fiction.
And that brings us right to the heart of the story, the thorium bet. See, instead of fighting for a slice of the world's limited uranium supply, India decided to look inward, to tap into a nuclear resource it has in massive quantities, right there under its own soil.
So, what is this stuff, thorium? Well, it's a radioactive element, but here's the catch, and it's a big one. It has to be converted into a fuel. Think of it like this. Regular uranium is kind of like a ready-to-burn log. You can just throw it in the fire. Thorium, on the other hand, is more like a pile of sawdust. You can't just light it, right? You first have to press it into a log. It's fertile, not fissile. And that one little detail, well, that's the key to this entire decades-long plan.
And this slide really lays out the strategic choice India's making. On one side, you've got traditional uranium. Yeah, it works straight out of the box, but there's not a lot of it globally, and the radioactive waste it creates stays dangerous for a very long time. But then you have thorium. India has tons of it. The problem? It's not a direct fuel. But, and this is the genius of the plan, if you can solve that puzzle, you get a fuel source that produces way less hazardous waste. India is betting that the long-term prizes of energy independence and safety are worth the incredible technical headache.
So how on earth do you do it? How do you turn this sawdust into fuel? Well, this is where the master plan comes in. And believe me, this isn't some quick fix. We are talking about a sophisticated, multi-generational roadmap to turn a national resource into a national power source.
Okay, pay close attention because this is the core of the whole strategy. Stage 1, you use your standard existing nuclear reactors to create a special kind of plutonium. Think of this as the matchstick, the spark you need to get everything else going. Now, stage 2, this is the magic. You build special breeder reactors. They use that starter fuel from stage 1 to bombard thorium. And they're called breeders because they literally create more fuel than they consume, transforming that useless thorium into a brand new, powerful fuel. Which brings us to stage 3, the ultimate goal. A whole new fleet of reactors that run on this newly created fuel and more thorium, creating a self-sustaining cycle that could power India for hundreds of years.
So it all boils down to this. The whole complicated multi-billion-dollar effort, all the science, all the engineering of those first 2 stages, it's all laser-focused on one single goal, turning that plentiful thorium into a very specific, very powerful nuclear fuel called uranium-233. That is the key that unlocks the whole thing.
Now, a plan this epic, this ambitious, well, it doesn't come cheap, and it certainly doesn't come easy. So we have to take a really honest look at the incredible promises of this technology versus the very real, very difficult problems standing in the way.
You have to admit the vision here is absolutely compelling. The physics of these future reactors suggests they could be inherently safer to run. We already talked about the waste. Producing significantly less of that nasty, long-lived radioactive stuff is a huge win for the environment. And of course, there's the grand prize, true long-term energy security and the chance for India to become a world leader in next-gen nuclear tech.
But then, you get the reality check. Building this sequence of highly specialized reactors is fantastically expensive. We're talking about massive infrastructure projects that take decades just to plan and build. And while the brilliant folks at the Baba Atomic Research Center have hit some amazing technical milestones, making this whole cycle actually profitable on a commercial scale, that's still a goal for the future, not a reality today. The path is clear, but man, is it long and expensive.
So let's look forward. Let's say India overcomes these massive hurdles. What does success actually look like? What would this new nuclear dawn really mean? Not just for India, but for the entire global conversation about energy.
Honestly, success would be totally transformative. India would go from being a country that imports energy technology to a country that pioneers and exports it. It would mean they had cracked one of the toughest nuts in all of nuclear physics, creating a brand new, more sustainable path for atomic energy. It would fundamentally redraw the world's energy map.
But when you strip it all away, this entire decades-long quest comes back to a simple and incredibly powerful vision. It's about a future where India's cities and villages are powered by a resource from its own land. It's about a grid that's reliable, sustainable, and totally independent, securing the nation's future for generations to come.
And so that leaves us with this final big question. This is so much more than just one country's energy project. You could say it's a test case for the future of nuclear power itself. If India pulls this off, their thorium quest could literally provide the blueprint for the rest of the world, redefining how we all think about clean energy for the next 100 years. The stakes really couldn't be any higher.